Good morning, everyone, and welcome back to another lecture of Web and Mobile Systems. So today we are going to start our discussion on React Native, which is essentially the technology that we will be learning in order to build native platform apps, or basically that is also known as mobile apps, or using the React Native library. So essentially up until this point, the flow of technology that we have discussed and that helps us to kind of develop all these different user interfaces for either the web or mobile platforms that we are going to learn was essentially along the lines of, first of all, learning HTML, CSS with the CSS framework, and then JavaScript along with the DOM JavaScript, or which is also sometimes known as vanilla JavaScript, which essentially helps us develop web systems, okay? The user interfaces for web systems. And then in order to make the process of the web system development a little bit more efficient compared to using just DOM JavaScript or vanilla JavaScript, we kind of ventured into the domain of React.js, right? And the specific things about React.js, or the fundamental aspects of React.js library that we learned, so this was basically a library, was in the form of how to write custom components. So first and foremost, it uses the syntax that we call as JSX that helps us develop HTML-like elements and not exactly HTML elements, because the system that React.js develops is not directly understood by the web browsers, right? So because the web browser understand what we call as the DOM API, and then the DOM API is something that is used specifically when we are working with mostly vanilla JavaScript, right? But when we work with React.js library, in order to speed up the process of rendering the elements on the web browser, it doesn't use a real DOM data structure. It uses what we call as the virtual DOM data structure. And that is the React DOM that we essentially use. And when it comes to React DOM generation, it uses a syntax called JSX. So with JSX, we kind of write custom components, which allows us to utilize the benefits of the React.js library, which is along the lines of making sure that our code is composable, that the applications that we develop is basically declarative in nature, and things like that. And that is achieved through the writing or through the design of our entire UI using custom components. And custom components are nothing but functional components or functional modules that we write using JavaScript as well as the JSX syntax, right? So we can combine those two features together. One is used to render the elements on the interface itself, and the other one kind of builds up the foundation of the app logic or additional app logic that we might need in order to program our UIs, right? So custom components, in terms of custom components, if you want to manage the data, and if the data management part is basically for the data that is declared outside of any custom component, then we use what we call as React props, okay, or sometimes is also known as React properties, but the technical word we use is React props. And then we use state management in the form of React hooks. It is implemented through React hooks, and the React hook that is basically used for state management, local state management, is known as use state. Okay, so basically the hook is known as use state, and this is for local state management only. That is state management or data management within a particular custom components. That is for the variables or the objects that you declare inside a custom component, and you want a way to manage that. That is basically done through the React use state hook, right? And a variation to the state management in the form of global state management. That is, if you want to manage the state of data of multiple different custom components and then pass that data across, or want to be able to access those data from any other custom component, right? So what we are talking about here is, let's say you have 1 to n number of custom components, and then you want custom component 2 to be able to access the changes to the data that is made by, let's say, custom component K. So if you use local state management in such a scenario, if you use uState, then you will have to combine that with the properties of React props in order to move that data around to the custom component that is trying to access the data of another custom component, right? So even though that process is possible, it is a little bit lengthy. It is a little bit tedious in terms of implementation. So what developers essentially do in such situations, when you have the necessity for some sort of global state management, then they use third-party state management providers, which specifically in the case of the React.js library, one of the more popular ways of doing that is by using what we call as Redux, right? So we are going to look into Redux while we learn React Native as well. So that kind of will cover that particular portion, right? So we learned about those things, and in order to make your app interactive and dynamic, that is, move from the domain of static development of static UIs to dynamic UIs, wherein you change the state of your UI dynamically based on certain interactions with your users, okay, for whom you're developing your applications. We learned about the concepts of React form elements along with event listeners. So that is where currently we were at when we kind of covered most of the fundamentals of React.js library, right? So this is everything with respect to your web systems, okay? You can use mobile devices to access these web systems, but depending on how well you have written your CSS, and sometimes you can also combine that or put those code logic within JavaScript syntax as well. But depending on how well you have addressed those responsive behavior, either through using media queries in CSS or writing those same media queries, but using JavaScript syntax, if you have done a good job with that, then maybe you can make your web systems a little bit more responsive in nature, and you can give a good user experience when your users access these web systems from mobile devices, right? Nonetheless, making responsive web apps, okay, that is web apps that are viewable through mobile devices and not just the desktop screen viewport, they don't make those apps itself, or we don't call those apps native apps, okay? And essentially, the whole concepts of native app is to kind of develop your UIs or your applications that is kind of designed from scratch for the native platform, okay? And when we refer to the native platform, what we mean by native is basically apps that are designed either for the Android platform, okay, which is the operating system, one of the operating systems that is used, and everybody knows the other one, which is the iOS one, right? So if you design a UI which is specifically meant for one of these two platforms, then what we refer to them as is basically a native app, right? So that is the kind of like the idea behind the keyword native, right? Sometimes people can call it mobile apps, okay? But a lot of the times you will also see this interchangeable naming mechanism where they, instead of calling it a mobile app, they call it a native app itself, right? So rather than learning an altogether new technology and a new language, the motivation is that we want to continue this trail of technology that we have picked up in the last couple of weeks, right? And we want to extend that and learn only some of the specific syntactical components that is necessary in order to begin our journey into coding native apps, right? So that extension, that logical extension of learning this technology is the React Native library. Okay, so this is also a library. It's not a framework. This is not a runtime environment. And this is not a new technology altogether. This is a React Native library is basically an extension of JavaScript library, just as the React.js library was. But it has nothing to do with any kind of hierarchical dependencies with React.js as such. So essentially, just as how in React.js, it borrows all of the fundamental components of the JavaScript language, right? Whatever JavaScript can do, you can essentially incorporate that in any project that you're developing using React.js. And then on top of that, the React.js library gives us some additional features in order to make our development process more efficient. Similar to that, the React Native library provides us with unique elements or constructs that is necessary for us to develop native applications. But in addition to that, if you're coding using React Native library, you can use all of the functionalities that you have learned within React.js library. So that means the concept of having custom components using props, the concept of having state management either by using use state or using React forms and event listeners. And we also learned about API calls as well here, using the React hook of use state that gives React.js use effect, sorry, not use state, but it essentially gives React some control over the state of the data and the behavior of the data that is external to the React application itself, right? So that was essentially the summarized overview of what this use effect hook kind of helps us achieve. So we can use all of those features. We can also use all of the features that was there in vanilla.js as well, which essentially is used to write the logic of your code, the logic of your application that you're developing. So essentially all of those features are ported in for usage, for your use within the React Native library development process as well, right? So that is why this is a logical extension, because you don't have to learn a new language. The language that you are still using is JavaScript. If you understand the fundamentals of the React.js library, then that is used to code a lot of the logic as well. But the environment is generated by using the components that is provided by the React Native library. So when we develop native apps using React Native library, in short, it is not that you are using JavaScript to code those environments. You are still using the new syntaxes that this library provides that essentially helps us kind of develop the native app environment. But as far as the logic of the app is concerned, right, how you're going to develop those different elements, which will be showed on your screen and things like that, those are still done using JavaScript and React.js library, right? So this is basically how the idea of development of native apps using the React Native library goes, right? So we are going to start learning about this environment. We are going to start learning about some of the fundamental components that are present or provided to us using the React Native library, starting with the setup, of course, and then moving on to developing some different applications within this environment. Okay, so going over some of the fundamentals first before we switch over to the implementation environment and start working with how to set up this environment itself. The first thing that you have to keep in mind is this is a library which is used to build native apps. Okay, so the benefit of going with a technology like the React Native library and some of its variants. So there are, of course, other alternatives as well, and I will talk about that in a short moment. But you don't have to learn technologies that are specific to certain environments. So what is meant by that? Well, if you want to develop, let's say, an iOS app, right? And if you didn't have the support for technologies such as React Native, then you would have to learn from scratch how to essentially do iOS programming. And this involves learning the environment of Swift. This involves learning the syntax and the logic, how to code the logic using Objective-C. Similarly, if you wanted to develop a native app for the Android platform, then you would have to learn Android programming from scratch, which will require you to learn the syntactical language of Kotlin, which is used for Android programming, and be aware of how to work with Java, right? So in React Native, you don't have to learn a new language. You don't have to learn a new environment, right? All you have to learn is the special environment components that is provided by this library, which needs to be coded. And that is not a big order of a task if you compare to having to learn how to code using a new environment and a new language altogether, right? So that is basically the benefit of opting for a technology like this over learning specific programming languages that is specific to a certain operating system environment, okay? So again, as we discussed, you need to have a solid grasp on the JavaScript fundamentals, specifically things like how to declare an object, destructuring an object, how to declare an array of objects, destructuring the array, how to write loops, how to write conditional statements. Then you need to know the different aspects of React library, which we pointed out here, all of the different things that we talked about here, and other niche things such as conditional rendering and things like that. And as far as React Native itself is concerned, you don't need any prior knowledge as to how that environment works, right? Essentially, just like when we started off with React, most of it was to understand the environment of React.js library, right? So that will be the same here as well, that you don't have to learn a new language, but you do have to, when we start learning, you will learn step by step of the different components, the major fundamental components that are involved to build a fully functional UI for the native platform, okay? So we already talked about React.js, so we are not going to discuss that again, but keep in mind, React Native is a library by itself, and it provides us with a collection of different React components, which will be used or which will be transformed into the native widgets, right? So native widgets are basically different subcomponents, or you can call it functional modules that are built and then rendered on the mobile platform screens. And that platform can be both for the iOS or the Android. So you don't have to worry. Essentially, when you're developing your platform or your app, you don't have to worry whether, well, that's not completely true. You do have to worry to a certain degree whether you're developing it for iOS and Android, because there are some components within the React Native library which is not universally applicable for both iOS and Android. And this stems from the architecture or the support of iOS and Android platforms, specifically speaking, because there are certain things which you can do on Android devices that cannot be possible on iOS, and the same applies for iOS as well. So when you kind of are navigating yourself in situations like that, that is the only time when you have to kind of take into consideration the React Native components, which are specific to that platform which you're trying to develop, right? And you will probably have to give a conditional support in situations like that, where you have to check the OS first and then implement the different widgets that you're trying to implement, right? But one thing that you have to essentially remember is that if you work with vanilla JavaScript, right, and we're developing web systems, you had the concept of DOM there, right? So here you had the concept of what we call as the real DOM, which the web browser understands, right? And they will be able to kind of translate your code, which is in HTML, and then transform that into a real DOM and then show that on the web browser itself. When you work with React.js, right, there is no concept of a real DOM. There is the concept of a virtual DOM, which essentially is kind of captured by this React DOM component, which essentially helps us to transform that, right? So we use what is known as a Webpack, which is a third-party compiler that transforms this virtual DOM into the real DOM itself, such that the web browser can essentially understand what have you written in the JSX syntax, right? But the beautiful thing, not the beautiful thing, but essentially the thing about React Native library is that there is no concept of a DOM structure. Okay, no concept. I mean, there is a hierarchical structure, but it is not the web browser DOM that is used. Okay, so that means there is no concept of HTML elements or even HTML-like elements in React Native. Okay, so when you are rendering your native applications on the mobile platform, remember that there is no concept of the web browser DOM, either real or virtual in nature. And that is where React Native comes into the picture, because it provides us with these different syntaxes or different components which can be understood when deployed to either Android or iOS as to how it needs to be rendered on those particular platforms. Okay, because the way iOS treats different components like different sections on the mobile screen, or how to kind of render buttons that you can touch and interact with them is a little bit different from Android from time to time, right? So how is it, how, if you write a React Native application, how should it be transformed if it is deployed to Android and if it is deployed to iOS? So React Native gives us those different components. But in summary, what you have to keep in mind is that you cannot use HTML tags. So even in React.js, when we were writing JSX syntax, right, we were still using, we said that we were generating HTML-like elements, but we were still using a syntax that is a lot similar to HTML, right, if we wrote the code there. So the same is not applicable here anymore. We have to use these different React Native components in order to generate our environment itself. So that is something that you have to keep in mind, right? So that there is no direct equivalent to the HTML tags when it comes to working with React Native, okay? In addition to that, React Native also gives us some other components that helps us take advantage of the native platform APIs. Essentially, that means like you can use the phone camera if you want to use the sensing devices that are present on your mobile phones. Like, for example, you know for a fact that there is GPS that is there. There is accelerometer, which checks how fast the phone is moving. There is gyroscope sensors, which kind of keeps a track of the orientation of your mobile phone, whether you're using it in portrait mode or whether you're using it in landscape mode and things like that, right? So these are considered as APIs in itself, right? So the thing is, these APIs are not developed in JavaScript, right? They're developed using the traditional language that the platform is built on, right? So if it's Android, it has a different language and environment for those APIs. If it is iOS, you get the point, right? So if you're building your main application using JavaScript as your primary language, then there needs to be a bridge between the language in which you're developing the app versus the APIs that you need to integrate it with, which is written in an altogether different language, right? So that gap bridging essentially is facilitated by the different syntaxes of the React Native library. Okay, so in short, you can remember that React Native helps to bridge this gap between JavaScript code, which is essentially what you will use to develop your app logic, and the native platform code, that is where you will deploy it, right? So the entirety of your deployment environment is written in a completely different logic than the language that you're using to develop your app. So there needs to be something that kind of bridges this gap, and that something essentially is React Native, okay? So later on, when you become more advanced in this line of work, if you do choose to pursue this, you will kind of find out that just because React Native bridges the gap between JS and the native language doesn't mean that you cannot integrate native language code within your JavaScript code as well, right? So essentially, there is no clean cut between your app logic and your native platform widgets and the language and the environment that it uses, right? So that is something to keep in mind. So if you take a look at a typical React Native code, and then sometimes people say that it's not just React Native, but it's basically a combination of React and React Native, because we essentially have to use, in order to kind of inherit the benefits of using the React.js library, all of the fundamental React components as well, all of the different features that we learned in React, that is still in some way going to be present here, because that will essentially consist of the bulk of your app logic, right? And then the React Native is kind of like the, as we discussed here, it's basically like the gap bridger, the bridge between the app logic code, which is written in JS, versus the platform on which you're going to deploy it and the language and environment that it uses, right? So here, if you develop an application, this is what it is specifically going to look like, okay? You will create an app component, which is basically going to call a callback function, okay? And the callback function, this is an arrow function notation. You should be familiar with this at this point of time. So it takes a component here, or it takes a parameter, which is going to be a prop, assuming that it is designed in such a way that it's going to receive values from externally when this particular app component is called. And then it takes this parameter, passes it on to the function body. And notice how the function body has a return statement, just like we did in React.js itself. And within the return statement, we write the logic that will be rendered on the mobile phone screens or the handheld device screens, like a Note or iPad or things like that, right? So all of those are considered to be native platforms per se, okay? So anything that is not like a desktop, laptop system, or that is not accessed through a web browser, think about that being considered as a native platform in this particular case, right, in this discussion. So here, if you had written this code in web browser, what you would have done here, if you think about it for a second, let's say if we want to write the same code that is shown on the screen right now, and we want to write that in, let's say, React.js, right? So React.js, you should be familiar at this point of time. We would still have this return statement. Everything about the component declaration, which uses props, remains the same. So if I want to write this here, what would I have done? I would have created a div component here, okay? And then kind of the div kind of closes. And then within the div component, here I have a hello world text. So it's a text component depending on how you want to render it on the web. So let's say if you want to render it as a pure text in a paragraph fashion, then you would have created a p tag here. And then within the p tag, you would have written something like hello world. Okay. So this is a JSX syntax. This is built in React DOM. So using a compiler, when it is rendered onto the web browser, then it can essentially, sorry, not a compiler, but a transpiler. It can essentially convert what this means and make the web browser understands that, okay, this is the real DOM H div tag, and this is the real DOM P tag, and this is just a simple text. But as we already discussed here, there is no concept of a DOM when it comes to native platforms, right? It does not you don't build your applications which are supposed to be accessed over a web browser. So there is no concept of a DOM to begin with. So if you write a code like this, even using React, this is not native platform code, and iOS won't understand what is a div. Android won't understand what is a div or a p tag, right? So you need to use certain elements which can be essentially understood by either the iOS platform or the Android platform, right? Those are the two options that we currently have. We do have Linux, but that is not such popular when it comes to native platforms as such, okay? So what happens here that in React Native, there are certain elements, okay, which can be understood by both the Android platform as well as the iOS platform as to what, as a developer, are you trying to tell it to render on the screen, right? So one example that we are looking at here is that instead of div tags, so just like div tags can be used to create like, what do you call divisions on your UI, right? Meaningless division, so to speak, because this doesn't have any kind of semantical meaning behind it. Well, if you want to create something similar using React Native that could be understood by iOS and Android, we have to replace this div with a view tag, okay? And then we have to close the view tag as well. Similarly, if you want to render any text on the screen, okay, and you are coding using React Native, you have to replace all your text and make sure that you enclose that within this particular text stack, right? And this is also a little bit of a deviation from what we are used to working with HTML as well, because think about it in this way. If I had, let's say, if I was coding in HTML purely, right, just HTML, not React JSX, then if I wrote something like this, let's say div, this is a text, okay? If I wrote something like this, the web browser will still render this text, okay? Nothing significant will happen because of these div tags. That is kind of given, but the web browser still will be able to render this text. Similarly, if you wrote this code in JSX syntax within the React.js library, and if you wrote the exact same code within the return statement of a React.js component, then even through the help of the conversion of the React DOM, this text will be displayed. But in React Native, there is no support for such standalone text. So what that means is that if you would like to render any text data on the screen, then you would have to wrap them around these text elements, which is provided by the React Native library, right? So this is like a foresight into what will come later on, and something that you would like to keep in mind. So the two new components that we just learned about React Native, and we will visit them, and through practice, we will get more accustomed to them. But you can make a note right now that if you want to create divisions on your mobile screen, okay, and then arrange your data, then basically the equivalent of a div tag within the React Native environment is the view tag. And then similarly, if there is any piece of text that needs to be rendered on the screen, that needs to be wrapped with the text tag within the React Native library, right? So just two things that we quickly learn, and then that is kind of straightforward to understand, all right? So moving forward, what happens now that if you develop or if you write a code like this using React Native, and you go or take this code logic and you try to deploy that on the native platform environment, right? How does this essentially work? That is the main thing to understand after we understand that how or what is the differences in the code compared to the previous environments that we have worked with. Now, once it is delivered onto the desired platform, what or how is an iOS device able to understand this, or what does an iOS device see when this is deployed onto the iOS platform? And comparatively, we can also ask ourselves the same question, that what does an Android device see in this code when it is deployed to an Android platform? So essentially, the power of React Native is that it provides cross-platform support. Okay, so that means within its library, there are basically translation of how its different components. So for example, you have a view, you have text input, you have text, you have image, and all of these different types of components are there in React Native, right? So the library also consists of the directives, which tells the Android platform, or not tells the Android platform, which understands that if a app is deployed to an Android platform, then the view needs to be translated to the respective component on the Android platform, which can understand how to create divisions on your screen, right? So for example, if you use a div tag on the web platform, that is, you know what it does, right? So now if you use view platform or view component or the view tag on React Native, then if it is deployed to an Android platform, this view will get translated to Android.view. And then if you deploy the same application on an iOS platform, then the view tag will get translated to the UI view tag, which is basically the native tag that is used in iOS programming, right? When you develop it using Swift or Objective-C, we use the UI view tag. If we do it, if you learn the development in Kotlin, you will realize, or you will learn, that it uses Android view. So this is what is meant by the nature of providing cross-platform support, is that React Native understands how it needs to treat its code if it is deployed to these two different platforms. Okay, so similarly, text input is transformed into edit text tag on Android, and then UI text field when it is deployed to iOS. And similarly, this is on the web, it is treated as input. And we all know how to use input, right? Input can be to take input from the user in the form of text, in the form of username, password, mobile phone data, and file upload, and all of those different things, right? So few things to know, that there are, of course, variations of the same tag that you are probably familiar with using on the web programming platform. So you have to learn these new tags. This is the part, that learning these new tags and how it compares to the tags that you're already familiar on the web platform. This is your learning curve. Well, at least one of your major learning curve when it comes to fundamentals in terms of developing using React Native, right? Because beyond that, React Native takes care of how these tags, which has some corresponding similarity in terms of what it does to the web platform tags, how it needs to be transformed if your app is deployed to either Android or either iOS. React Native will take care of that, right? So you don't have to learn that part, but you do have to learn the similarities of the tags that you have already been using. What is the corresponding tag to do that same thing in React Native? That is what your first learning curve is going to be all about, okay? So this is the conversion of using these tags and how it should be utilized on the platform. This is the compilation process in React Native, okay? So remember, JavaScript is an interpreted language, so there is no compilation going on as far as the language is concerned. But when the whole platform or the application is developed, there is a compilation process which kind of helps to determine how those React Native tags needs to be transformed depending on the platform that you are deploying it. And in addition to that, the remainder of your app logic will be written completely in JavaScript. So please make sure that if you yet do not have at least a fundamental grasp on the JavaScript language and the React.js components, please keep on revising that. Otherwise, kind of undertaking this particular learning process in React Native is going to remain as difficult, okay, if you are not fully comfortable or fully confident on the basic nature of JS and React.js. So we'll still be using state management. I will show you how to do global state management using Redux, okay? That kind of makes your life easier in certain situations. You still will be using props. You still will be requiring API calls. And you still will be transforming your data, okay, using different logic, like running loops or conditional statement, conditional rendering, and all those kind of things, okay? Remember the fact that the app logic is not compiled. And that goes back to the fact that JS is not a compiled language. There is no compilation that will take place within your language itself or within the logic of your app. And the logic of your app, since it is written using JS, there is no compilation. But once the hosting process takes place, that is, once you take this whole application and you try to deliver that to Android or iOS, a compilation will take place at that time to figure out how to transform these different tags into the respective tags that is understood by those native platforms. That is the only time that you will compile it, right? And the app essentially runs on a JavaScript thread that is hosted by React Native. Okay, so that architecture is important for us to understand here, that when you develop a React Native application, okay, you write your app logic in JavaScript and React.js, whatever that app logic is, and then wrap it around all of the different components that is provided by React Native. Okay, so there is this clean separation between the two different contextual aspects that you're going to be using when developing native platform applications using React Native. The first is the main logic, the programming logic, which will be written in JavaScript and React.js. And then you will wrap those, just as we saw here in this example. So this is all React.js, this is coming from React.js, but the main components that needs to be rendered, they are wrapped around these React Native components, right? So that is the part which is wrapping your app logic. Now, what you do is once this code is ready, you take this entire thing, okay, and then you send it for compilation, okay? And when the compilation process takes place, it basically transforms all of these React Native elements to the respective elements of the native platform, whether it is iOS, whether it is Android. React Native will figure it out during the compilation process. And what happens is that the app logic itself is hosted on a JavaScript thread, okay, and that threading model is basically multi-threaded. If you are a little bit familiar with how multi-threading works, okay, coming from Java itself. So this is hosted on a particular thread on the JavaScript virtual machine, and that app logic is capable of interacting with the native platform APIs, which are there, such as the camera modules, the sensing modules, the GPS, and all those essential features that is provided by any kind of smartphone of this current day and age, okay? So there is going to be a downside with respect to the performance if you compare application development using, let's say, Swift or Objective-C for iOS, and then Kotlin for Android. And that extra step that is required for coding using React Native is essentially this compilation process, right? Because there has to be a step, an extra step, which is not required for your development in native languages, is this compilation part where you have to transform all the React components into the respective components that can be understood by the native platform, right? So this process is computationally intensive, but at the end of the day, this is a one-time process. Given that you don't keep on updating your app very frequently, and then that requires us to incorporate more and more React Native components. So remember, if the situation, and I cannot think of a practical example where this situation might keep on happening. If your app requires very frequent updates for some weird reason, then React Native is not the technology for you. Because if you very frequently keep on performing this compilation process, then that is going to have some kind of effect with the performance of your application on the native platform. In such a situation, you're probably better off using or learning the language that is built on the native platform itself, right? Something to keep in mind. All right. So this is the React Native development or the documentation page. We will be using this very frequently. So essentially, all of the information that we have with respect to, or all of the information that we need with respect to developing our apps using React Native, that is essentially available on this particular documentation page. And then we will be kind of following mostly this documentation page, just like we had a documentation page for Tailwind CSS, for React.js. We don't have specific, but we can say that we have documentation page for JavaScript and stuff like that. So all of your different components that are used. So this is the most important part in development, in components. This is the reference that you will specifically need. So the different components that are categorized within React Native is in the form of core components, which essentially gives you all these different components that will be essential for rendering on a native platform screen. It gives you all of these different props that can be used. So props is coming directly from React.js, the concept itself, but where you will use the props and how you will use the props, it gives you some information and directives about that as well. And it shows you a little bit of the different object types that are used here. But more than 50% of the time, you would be spending your time in the core components. And you can see that the list of actual core components isn't that big. Okay, so it is not an insurmountable amount of tasks. And anytime you kind of want to understand that how to incorporate something on the React Native environment. So let's say we want to put an image. So all we need to do is come here, and it provides us with the boilerplate code of providing certain examples within this particular functional component, right? Don't use class component. You can if you want to, if you're comfortable with this, but right now the way to go is using functional programming for React and React Native, and then using React Hook to make your life a little bit easier rather than having to write a class component. The only time you would have to kind of resort to class component writing style of React Native is when you know for a fact that there is no React hook that can help you achieve a certain thing that you're trying to do. In a situation like that, then and only then is when you have to write your components as a class declaration rather than as a functional declaration, which is much more easier to code in terms of development. Okay. The other thing that you have to keep in mind is that just like there is no, so let me just write this down because this is an important piece of information. So no HTML or HTML-like support in React Native. And the reason behind this is the first point. The reason behind this is because native platforms don't understand HTML tags, okay, or JSX tags either, which is basically HTML-like tag. Similarly, this is going to come as a surprise. I don't know, maybe, but there is no CSS support for React Native or native platforms either. Okay, so I don't know how surprised you are with this, but essentially everything that you know about CSS and how to use those CSS, you cannot use those CSS syntaxes as is, right? So you have to either know how to write CSS in JavaScript. That is your one option. So what are the solutions to this? You need to know how to write CSS in JavaScript syntax. So essentially, as you can see here on this documentation page example here, it gives us an environment which it understands that is known as this style sheet tag, right? So within this style sheet tag, essentially, you have to call the method create, and then within create, you pass in an object that is going to store all of the different CSS rules that you want to apply to wherever you will call this particular component here. Okay, so whenever you add this styles somewhere, so here you can see that in the view tag, which is nothing but a div tag for the React Native environment, it is applying as a style property. Okay, this is coming from HTML style attribute inlining. It is just calling on the styles.container, which is basically what was created here. This is the styles.container. This is an object, okay, and this is a key. So it is calling on styles.container. And then, but notice how the CSS rule has been written here. If you had written this using CSS syntax itself, right, there would have been an hyphen here between padding and top, and the T here would have been in small letter, right? That is the CSS syntax. But React Native does not understand CSS syntax, okay? So that means if you want to go this particular route of applying CSS to your React Native files, then you would have to use this style sheet environment and then the create method. And within that method, you will have to pass in as a parameter CSS rules that is written using JavaScript syntax. Okay. And the main thing to keep in mind is when you transform your CSS rules into JavaScript syntax, you just switch to camel casing. Okay. So that means you lose the hyphen. So if you have something like, let's say in CSS, we know if we want to apply some sort of a background color, okay, to any particular element of your page, you use BACKGROUND dash color, and then you provide some sort of an RGB value or some sort of a hex value, and then you provide that. So this is how the CSS syntax works. If you want to write the exact same thing in JavaScript, all you do is you write it in camel casing, you lose the hyphen, and then you continue with your value itself, right? The value can still remain as RGB, it will still understand that, or you can use hex code here, right? So that is how you kind of lower this, you know, the steep learning curve of having to learn how to redo CSS all over again, right? So as long as you remember how it was written in CSS, you will be able to transform that into JavaScript. As long as you're using it inside this React Native component or React Native element, which has been created for us, which is known as style sheet, okay? And you call the create method and you pass in all the rules there within the create method. So that is one option of trying to figure out, not figure out, but applying CSS. This is the first option. There is, however, a second option, a second solution to not having direct CSS support. You will not see any CSS.css file within a React Native project or within a native programming project, right? So the other option is to use a CSS framework. And that is the reason why we specifically learned about Tailwind CSS. It is one of the frameworks that you can use. Of course, there is the Materialize UI framework. You will see some developers using that. Bootstrap is also there. You can use that, but your apps will look very similar because it is template based, right? So if you have worked with Tailwind CSS after it has been demoed, some of you have already worked with it in your projects and stuff like that. So there is some level of familiarity as to how it works. So if you know how to use that, and if you wouldn't want to write CSS like how it is shown here, right, then the best way to go about it is just to integrate Tailwind CSS to your React Native project, and it will work, right? But there is certain differences with respect to how you can integrate Tailwind CSS because you need the correct package of Tailwind CSS that is meant for React Native, or that is meant for, in another way of saying, for native platforms, right? So essentially right now, for React Native integration, unless it has been further updated, the package that is used to integrate Tailwind CSS to native platform projects that is written using React Native, we use this package called Native Wind. Okay, so we'll talk about that later on down the line when we discuss a little bit more with respect to what we have, right? So this page is going to be your best buddy. So might as well kind of bookmark this page, and all you have is probably like what, 20-ish new components that you have to be familiar with. So as long as you know what you're trying to do, you can kind of visit these different documentations and you can see how to kind of implement that, right? So if you want to add a button, you can simply just take this, press, keep it there, and you can see here, you have the same event listener process like you had in your React.js, right? This is exactly how you did it in React.js itself. It's just that the event is a little bit different because we don't have clicks. Okay, we have to touch the screen, right? So essentially the event listener then changes from on click for buttons to on press because you're essentially, well, pressing it. Okay, so all of these different things are there. Some of these views are specific, or some of these components are specific to behavior on a mobile device. So example, the scroll view, the section list, and those kind of things, specifically this status bar here, these are specific to native platforms, right? And these are not something that is specific or that is also available in the HTML structure, right? So you would be mostly referring to this website in order to kind of keep a track on remembering how to work things up, right? So now coming to the setup of how to setting this environment up, we will be following this link. So you can kind of copy and write this link down. By the way, the slides are also available on Moodle itself. So if you're wondering how to copy these links, you can just go to Moodle, download the slide for React Native Part 1, and that will give you this link. Okay. So when it comes to setting up the React Native environment, we have two different options. One is beginner friendly. The other one is, well, it's kind of subjective to say that it's not beginner friendly, but to a certain degree, it is not beginner friendly actually. Okay, so the two options, the first option that is beginner friendly is to use another third-party provider that is known as Expo. Okay, you can visit this site. This is what it will give you more information about what Expo is. Actually, might as well show it to you. So what Expo does is basically it provides a wrapper around your React Native applications. Okay, so what happens is that instead of deploying my React Native application directly on the native platform itself, so for example, let's say we have this iOS platform, right? And then we have written this React Native application, which is written using the library components of React Native, React, and JavaScript language. Okay, so now instead of taking this and delivering it and trying to host this directly on, let's say, the iOS platform or the Android platform, what we do is we take another step in between, is we take this environment, which is, known as Expo. We take this environment and we put, or we wrap this React Native application within this environment itself. Okay, and then once this environment has now wrapped our entire React Native application, we take this Expo app. At that point of time, we don't call it a React Native app anymore. We call it an Expo app. We take this Expo app and then we deliver that to the platform where we are trying to launch it, right? So Expo has a better translation of how the app needs to behave when it is deployed on a certain platform. So Expo can handle all of those translation for us, rather than us having to write how some of those translation features are going to take place, right? So this is the reason why this is a little bit more beginner friendly. In addition to that, Expo provides us with a lot of different third-party packages that can be further integrated with our React Native project. That gives us some more freedom as a developer to kind of have the flexibility to achieve certain things for which we would have to write the code from scratch. Okay, so it provides all those different packages, right? And Most of the packages that we will be using from the Expo environment is not from directly from the Expo environment. There are certain packages which are just there, some third-party packages. We will be using mostly the styling components. Okay, so instead of having to write our own styling rules, there are certain third-party packages which provides us with pre-styled components, right? How the button is going to look, how different section is going to look depending on running it on a native platform and stuff like that. So those third-party packages we can integrate directly to our React Native applications, right? And then we will be deploying that. The other option, the second option that we have, so that is mostly like about what React Native or what an Expo app helps us achieve, right? So you can kind of go over those discussions here, and you can see that the secondary option, which is the bare React Native application, which is basically just like we work with React JS when we installed a bare metal kind of like an environment where a React JS application can run. We can do the same thing in React Native as well, which is basically the second option to install what is known as the React Native CLI. The problem with this is that there is no support for developers here, right? It gives you more freedom than Expo app, yes, because you're not constrained by the Expo environment. But in React Native, you have the freedom to do whatever you want if you're using the command line interface method of setting up the environment, but you get no support. So that means you have to import your packages, you have to kind of write from scratch the different directives that is required by your app's logic that will be transformed to the native platform environment. And all those features, so these features that are listed here, some of them is a little bit advanced features and stuff like that, those are not supported by the bare metal framework. So the bare metal framework is much suited for developers who are either going from intermediate to advanced, or they're advanced already and they know what they want to do, right? That is why for beginners to test out the environment, to learn the environment, it is much easier to go with Expo. Okay, so but Expo app is available on Apple Store and Google Play Store as well. So depending on the devices that you guys are using, what phones you're using, you can go ahead, maybe right now if you would like to, and download this app that is known as Expo Go. Okay, so this can essentially help you compile your applications and test it out as well, okay, on your phone itself. So you can directly see through this app how your application that you're developing is going to behave on your phones itself, right? So you can go ahead, maybe now or later, whenever you feel like it, you can download this Expo Go app as a way to check your implementation and your testing and how your development is going. The reason why the Expo Go app is kind of like important as well is you see here, for all of these example codes that you see on the React Native documentation page, it gives you this QR code. So using the Expo Go app on your Android devices or on your iOS devices, you can also run it on Note and iPad as well. If you just scan this QR code, then it will show you how this entire application that is written here is going to actually look like on your mobile devices, right? So the same goes for your application as well, as to how it will look. So that is essentially the benefit of using the Expo Go app on your phones and stuff like that. Of course, I will show you how to do it using the simulators as well, but this is another alternative option of how to test out your applications, or how to quickly take a look at a documentation demo and figure out if that is what exactly do you need or not. Okay. The only thing that you have to keep in mind is that your Expo Go application that is running on your smartphone or your handheld devices, they need to be in the same Wi-Fi network where you are kind of hosting your local host, your development system, right? So if I'm using this desktop right now to develop my application, I need to make sure that my Expo Go app, which is on my mobile phone, is also on the same Wi-Fi network, or otherwise I have to set up a tunnel to connect to wherever my app is being developed, okay? So as we talked about it, in terms of Expo, it is a third-party free-to-use service, all right? It is a managed app development workflow. So it acts as a wrapper around your application itself. All right. And there is a programming note here that the React Native development environment can be a little frustrating. It is true to a certain degree that sometimes Expo might not behave in a way that you would like it to behave. There might be some device problem with respect to it's starting up, right? Sometimes it might just freeze. Things like this might happen, right? Sometimes you have done nothing wrong. You ran the commands that you were directed to, but still it does not behave the way that you expect it to behave, right? In such a situation, things can be frustrating. You might have to start and restart your app multiple number of times if you are unlucky to be in a situation like this. I have been in a situation like this, not a situation, but multiple times as well. So a note to yourself is that don't get frustrated, right? Environmental problems are something that is very common whenever you're learning a new environment, whenever you're learning a new technology, right? So if it bugs you too much, and no pun intended here, then take some time off from it and come back to it. Rethink about it systematically, that what could be the problem. Try restarting your server, your applications. Maybe next time you might not face the same problem, right? But don't lose your confidence because of issues with the environment. It is very natural to face those issues. And a lot of us, and all of us mostly, face such issues whenever we deal with a new environment, right? So don't let yourself get discouraged, don't get frustrated, or don't hate the environment just because it is giving you some problems, all right? Another benefit of Expo is that, as we already discussed, it provides a lot of utilities that makes our life much easier as beginners with respect to this environment. And of course, what you pay for it in order to get all of these development utilities and these benefits is the fact that you lose your freedom to move outside of the Expo environment. Okay, so you can only do the things that Expo provides, right? But it is very essentially good for beginners, right? And the React Native CLI, it is a bare bones CLI. Okay, so that means you have to import all your packages, you have to write everything from scratch. Okay, there is no support, there's no utility for you. And in terms of simulation, how to test your code out, you wouldn't get this QR code support that I was just mentioning here. You won't get this QR code support and check it out on your phones very easily. You won't get those benefits, right? So you will have to install a simulator, which we will do regardless, so that you are aware of how to do it in the React Native CLI environment of setting up this environment, right? But you do get the benefits that you can configure and manage everything, right? If you're comfortable doing that, you can control all of the stuff. And the added benefit that you get here is that you can connect your JavaScript code that you're using to write your application's logic with the React Native code, not the React Native, the native code of the particular platform on which you're deploying it, right? So that means you can mix your JavaScript code with Objective-C. You can mix your JavaScript code with Kotlin, depending on whether you're sending it to an iOS platform or whether you're sending it to a Android platform, right? So again, we talked about this already. When using Expo, essentially what we are doing is we are taking our application, wrapping it around this Expo client, that is what we call it, and then we publish this Expo client to the platform. And there is no restriction with respect to publishing your apps itself. That is, you can take an Expo app. So once it is wrapped by the Expo client, we no longer call it a React Native app per se, it becomes an Expo application. You can publish this if you want to send it to a production environment. You can publish your Expo apps to Apple Store and Google Play Store as well, right? So you don't lose anything in that regard that, oh, I cannot publish this to a proper Play Store or the app marketplace. No, you can do that, right? Also note that there is a separate marketplace for your Expo apps as well on the Expo website. So all the people who have developed different Expo applications, which are built using React Native and stuff like that, you will find those examples there in the Expo marketplace as well, right? So you can clone those projects and you can kind of, modify those projects for your own design purposes, and you can use them wherever you want to, right? So to summarize everything, and to kind of introduce you all to the alternative technologies that are available in this environment, because this is not the only technology that is out there. React Native is not the only library which is used for native platform development. So what is the benefits? What are the disadvantages? You need to be aware of that if you're beginning your journey, learning a new environment altogether. Okay, so as far as React Native is concerned, mobile app development is not about writing JavaScript code and running it on any platform. Okay, it is about learning the React Native components and then executing it on various platforms, right? The app logic is what is written using JavaScript and React.js, but the mobile platform development part is done by using the components that is provided by the React Native library. So you are essentially mostly focused on learning in terms of mobile app development, the React Native components, specifically talking about that, assuming that you guys have a firm grip on JavaScript and React.js itself. Okay, there is very little cross-platform support for styling. Styling is a kind of like a drawback when working with React Native, because if you think about native platforms like the iOS development platform, the Android, there are a lot of third-party support for styling your different components. But in React Native, there is not many cross-platform support for styling. Okay, you would have to use third-party libraries, and I will show you certain libraries that can be used to make your life a little bit easier when it comes to styling when we have React Natives. Okay, we don't have many pre-built components either, so we can just see that as an example here, that we talked about the fact that there is only what 20-ish core components, give or take, right? That's pretty less if you think about it for an entire technology. And that is less because you don't get support for pre-built components. That is the higher degree components that is there, which has a higher level of abstraction. You don't get those features in React Native library, the React Native library itself. You just get the core stuff, you just get the fundamental stuff, right? In contrast, if you use other technologies such as Flutter and Ionic, there's a lot of pre-built support, right, for the different components. Okay, so React Native is mostly bare bones, and so if you want to use or have pre-built component support for, let's say, developing different types of buttons, different APIs, different icons and stuff like that, you would have to integrate third-party packages to your project code. Okay, there are certain limitations of React Native with respect to deploying it on different native platforms. Depending on the type of device or the device orientation, sometimes you would have to perform certain conditional rendering in your React Native code, which will require you to first check the type of operating system, check the device orientation, and then kind of code the behavior of your UI, right? So those are certain circumstances where you do not have universal cross-platform support, and you will have to be aware of where you're deploying it and how it behaves, right, in those situations, right? The other thing is React Native library is updated very frequently. Okay, regularly is the word here, but frequently is what it happens, right? The problem with that is sometimes these updates are going to be app breaking. So that means you developed your application 6 months ago, some update came, there is a good chance that it might break your app, right? In such a situation, during every app update, you will have to revisit your app logic, you will have to revisit your components, and you will have to make those required changes, right? And that in some cases can be a little bit frustrating, but it is a growing environment, it's a growing library. So it is not, you know, evolutionarily stabilized as such. So you will have to deal with it, okay? And the other thing is, since React Native only provides core platform support, right, core component support, and as we already discussed, for either styling or for other pre-built components, we will have to integrate third-party packages. You will also have to keep a track of the updates that are done to these third-party packages as well, because when these updates take place, you would have to kind of make sure that you abide by those changes in order to make sure that your app doesn't break, right? So keep in mind that as long as you're within the Expo environment, things are a lot managed here. So there is like the amount of chaos that will come from app updates or library updates will be minimized, but it will not be nullified completely, right? So that is why Expo is a little bit more beginner friendly. However, if you're working with the bare bone environment, which is the React Native CLI environment, then this update effects will be quite magnified and you will be feeling it, right? Because you will have to take care of everything, all right? So there will be a lot of bugs present here because, as we said, this is still a growing library, okay? This is not a fully stabilized version, so you will get bugs. You will be told to do certain things in documentation. You do the exact same things, but you will get the bugs, right? You will face those situations. So debugging is your best friend there. Please make sure that you understand where are the breakpoints of your app logic, and please make sure to put some sanity checks there in the form of console log statements so that you can keep a track of what you're doing at every breakpoint, right? So that is kind of pretty important so that you don't get frustrated very easily, all right? The alternatives to React Native, you can build your real native apps in iOS. We already discussed about this. You can either learn a new technology that is specific to a particular platform, like Objective-C and Swift versus Java and Kotlin for Android platform. The problem is if you learn this, of course, you have to first learn a new language altogether. You have to learn a new environment after that. And the other limitation is you will be restricted to this platform. So that means if you become an Android developer, you specialize in Android development, right? If you have to move to iOS development, you cannot use the same syntactical set and kind of port that to your iOS environment, okay? You will have to learn a new environment and a new technology again. So you're limited by that environment. Of course, you have a specialization, but you are still limited if you're thinking about moving to the other environment, okay? The other option that you have to React Native is to build what people call as progressive web applications, okay? So these are applications which are web applications in its fundamental nature, but they feel like a mobile application, okay? But the problem with this kind of technology of developing progressive web app is that you cannot publish these apps to the App Store. That means you will not find this in Apple Store, or you will not find this on Play Store. You will have to access these applications using the browser UI on your native devices, and it will have a URL just like any other web system, right? So the problem with that is that if the user's smartphone or handheld device, whatever browser they are using, if that browser does not support the version or the type of progressive web app that you have designed, then your app is going to break. So it's no longer an app anymore. It will look like a broken web system at the end of the day, all right? Then there is things such as hybrid application development, such as Ionic, okay? People use this as well. The way it does is that it builds the React Native apps, the native apps is developed, and it is distributed to the app stores using web technologies, right? So that is a little bit different from how Expo works and stuff like that. Then it takes a web application and it wraps it as a native application. And there is no compilation that takes place. Remember, in React Native, you write it in JavaScript and then you write the components using React Native library, right? But then there is a compilation step that takes place, which transforms the React Native components into its corresponding components of the platform where you're deploying it. When it comes to hybrid app development, there is no compilation that takes place. So this slows down your application, right? So it builds a web app so you can use all of the DOM stuff and it wraps it around the native app environment. And since there is no compilation, that is going to have an impact on the performance because your app has to kind of figure out like, okay, what needs to be deployed or rendered on the native screen and stuff like that, right? So that can take a negative impact on the performance itself. There are some other technologies which are similar to React Native, okay? The way React Native provides cross-platform support, there are other technologies as well. Those technologies are known as either Flutter or native script. So be aware of them. So if somebody asks you, the problem is they just have different environments. They just have different languages. So if you ever wish to go to those languages, you can easily move to them, right? Not easily, but you have to learn the new environment itself. So for example, if you think about Flutter, right, which was developed by Google, it uses a language that is known as Dart, right, which is a combination of the advanced features of many different languages like C, C++, and stuff like that, right? So, and then you have native script, which is built on JavaScript, Angular, and TypeScript. So here the question is mostly like, okay, in this class, we have already learned JavaScript. Instead of Angular and TypeScript, we have learned React.js, okay? TypeScript is not a substitute for React.js, but you get the idea what I'm talking about. It's mostly a more stricter version of JavaScript itself, right? So if you're familiar with this language. So if we had learned Angular development instead of React.js development and stuff like that, if we had learned Vue instead of React.js, which are all front-end frameworks, then we could have probably opted for native script rather than React Native, right? But since we are kind of trying to make sure that we minimize the amount of new things that we have to keep on learning, we are using React Native compared to Flutter or native script. However, remember that Flutter and native script are both there for cross-platform app development, which is very similar to how React Native functions, okay? All right, so now we can finally, once we have taken care of all of the important stuff on the conceptual level part, we can move to our setting up of our environment within the Visual Studio Code, okay? So the first thing that I'm going to do is I already have certain things worked on here, but we are going to kind of use one of these folders that I created yesterday for some bugging problem that was happening. It was bugging me because there was a bug. All right, so right now I'm in React Hello World. I want to move outside of that. And then I want to move to this new folder that I have, which is AWS code commit. Okay, so I'll just check something here. All right, so it does have a tracker. All right, so I have created this project folder. It has a different name, unfortunately, for my cloud computing class. But all you have to do is kind of create a new folder, add it to the workspace. Okay, and then we can move forward from there as to how we are going to set up our first Hello World environment in React Native itself. Okay, so the information or the steps that we need to follow is also available in this documentation page here. I think we have already kind of opened that. So if you go here, you can see that there's the quick start information that is here. But we will go to the installation process. So the first thing that we need is what we call as the expo CLI command itself, so that it recognizes the expo operations. And then we need to set up the React Native environment. So it's a two-step process that we are going to be using. And then in terms of implementing the different packages, we have the option for either using Yarn, or we have the option for either using NPM. Okay, so I think NPM is something that you're already familiar with. We have used it. So I will show you some of the implementations as we move on to later projects of how to use Yarn as well. It is a little bit more swifter. I wouldn't say swifter is the right word, but it seems a little bit more cleaner when working compared to NPM itself. Okay, so once we do the Expo Go start, which you can find here in the environment setup for the React Native development documents as well, this is the one that we are going after right now. Okay, we are not going for the React Native CLI implementation. That's the bare bone one. That's mostly for intermediate to advanced users. We are going for Expo Go quick start option. Okay, now here we have either the choice of using the NPM package manager, or we have the choice of going with the Yarn package manager. Okay, so we will switch to Yarn later on at a different project, but now we will stick to NPM itself. All right, and the commands that you have to learn, execute, are just these two set of commands that is shown on this particular screen right now. So first you will have to install the Expo CLI, which is necessary to create the Expo wrapper so that we can wrap it. So first of all, go ahead, and this -g is a global command, so you're globally installing this. So if I do npm -g npm install -g and then the Expo CLI, which is Expo -CLI itself. So this is the first step that you guys need to do if you're working with this environment itself. So it will set up the Expo CLI. It will take some time. I hope it doesn't hang for me. But please go ahead and set this up. Okay, have you guys started the process for those who are working along?
Yes.
Yeah. So give it some time. I hope this does not behave the same way as my React.js library behaved, which it got stuck in the first execution and then I had to restart it. So I think, yeah, it will start. It's moving forward for me. For those who finish earlier than I do, go ahead and then execute this second command, which I'm highlighting on my screen, which is very similar to React.js, but instead of creating React app, we are creating an Expo app. Okay. Remember, although we will work with React Native, we will wrap it within the Expo environment. So that is why we want to create an Expo app, and that Expo app will create the React Native application environment. Okay. And then give the name of your application, just like you did in React.js, and use npx, because that will install and compile, build the project for you as well, right? So these two steps is going to take a lot of time, at least for the first setup. But once that is done, things will become a little bit more easier. So the name of the game when working with this environment is patience. You will have to be a little bit patient, because there will be a lot of packages involved. There will be a lot of installations from time to time along with bugs. Okay, so let's wait it up, and hopefully everything goes without any problem. If anybody is done, do please let me know so that I'm aware of where you guys are at. Okay, so while we wait for this, we can take a look at what you are going to get when this installation is finished. So if you pay attention to my screen back again and leave your installation as it is moving forward, you will get two folders within your primary root folder. Okay, so here you can see here that I installed, this is my root folder here, which says AWS code commit testing folder, but hey, you get the idea. But if you pay attention to this one, which I'm highlighting with my cursor right now, which is React Native Hello World, after the installation is finished, which means that this npx create expo app and then my app command has been executed and successfully finished itself, you're going to get two folders. One folder is the .expo folder, which is going to store all of the different packages that is required for Expo to operate itself. So we don't have to worry about anything that is inside that folder. You will come to this folder, which is my app. That is basically where the entirety of the logic is going to be present. Inside of that, you will see that there is an Expo folder. There is some assets folder, which will provide you with some of the icon images that will be used for your Hello World application. Remember, when we installed our React project as well, we kind of got some icons for the React development, which was kind of, transforming itself on the web browser when we ran the Hello World project. So these are all just the icons that we have from the boilerplate project setup, right? So you can remove all of these icons once you're done with testing out that the environment works. But assets is where you will put all your media files that you will be using for your mobile application, right? So you will put all of those media information there. Node_modules folder, just like React.js environment, this will store all the third-party packages and all the packages that you will use there. So other than that, your app.js is going to be your landing page, okay? And then you will have a configuration file for your compiler. You need a compiler here. Remember, there is a compilation that is going to take place. Babel is going to do that. And then you have package.json, which will keep a track of all your dependencies, all your script commands that you will have in your project, okay? So I am done on my side. It took me about 229 seconds. So is the rest of you done?
No, I ran into some errors. I'll have to figure it out later.
Okay. What does it say? Does it say anything specific? Are you using what is your system? Linux, Mac, or Windows?
It's a Mac.
Okay. Did you use the sudo command before npm? Make sure you use that, because you sometimes might need admin access to install certain of these packages.
That's what happened to me. Yeah, that's what happened to me. I used sudo after that, and then it just asks you for your password, and that's all you need to do.
Yeah, it will go through. For Mac and Linux, please keep in mind that you need to super user do it, these commands, because this will be changing, making change in certain directories where you need admin access to allow this program to install its packages. Okay. Window, it is running from an admin access perspective only, because, well, I'm logged in as an admin user and the behavior is a little bit different. Okay, for others who are working on Windows, it should be fine. But once this installation is done, okay, we will go ahead.
That's what it was. You guys were right.
Yeah. I think I have it written somewhere. Yeah, so it's here. Okay. But yeah, if you, okay, so just to generalize this comment, if you face any problem with package installation, the first thing try out is, did you try to install it using admin access? So that involves for Linux and Mac to run it as a super user do command. So just do sudo and then npm install and then whatever. The same goes for yarn as well. If you're using any package manager and if you hit a roadblock with respect to installation, first try admin access installation. And most of the times it will fix the problem. Okay. All right. So once that is done, the next thing that we want to do is actually create our React native environment, which will be wrapped inside this Expo project or this Expo client. Okay. So the way we are going to do it is we are going to create an Expo app, not a React native app, because that will take us into a different direction. We don't want to go that direction. That is a scary place to be in as a beginner. So we are going to run this command, which is npx, calling the directive. The command syntax is create Expo app. So just as we did create React app, but this time we are going to do create Expo app and then give your directory a name, whatever name that you want to give. So I'm going to go ahead and do it on my system. So please go ahead and try it out on your system. Okay. So we need to create an Expo app this time instead of a React app and give some name to your folder. So I'm just going to give something like my Expo app. Or you can give hello world or something like this, whatever that you prefer. All right. So that will install the packages and then build your project. That is also going to take some time. So let us give it some time. Okay. And as I was coming back to the discussion here, this is the project folder that we are already going to see. So app.js will going to be our landing pages. Assets is where you will have all of your media files and stuff like that. You have a git ignore file that has been created for you. Babel is your compilation process. So any package that requires additional compilation, which means that Tailwind CSS, remember Tailwind CSS requires compilation for every change that you make, right? So if there is a compilation aspect involved for any of the packages that you're adding, then that needs to be specified here in babel config.js. Okay, and I will show you later on when I show you how to do the Tailwind integration. It's a little bit, it's not as straightforward, but it requires some weird setup things to be done in order to get it running, right? So there's also another interesting thing with respect to Tailwind CSS. There is a library, there is a package, which is not about full integration of Tailwind CSS, but it only gives you the core Tailwind syntaxes that people more frequently use from time to time. So you can make a hybrid implementation of your styling files where you use the JavaScript way of styling that React Native provides using the style sheet component, and you can mix it up with partial Tailwind package itself, right? So anytime you're doing something that is complicated, you can use those partial Tailwind packages and simplify your life. And anything that is like a breakaway from the more frequently used CSS styling rules, you can write your own styling rule in those situations there, right? So I kind of like that hybrid way of doing it because I don't have to go through the whole strict way of integrating the entire CSS Tailwind framework, but I will show you that nonetheless. It's your choice, whichever one you want to go with. I will show you the partial one as well, which I kind of prefer because I don't have to do all this configuration stuff for Tailwind. I don't have to run the Tailwind command every time to recompile my whole thing, which sometimes you might forget if you're not running the watch command for your Tailwind compilation, and you might be thinking like, why it is not working, right? And like I have faced that situation multiple times where I think I've done everything right, but it does not show up on my like rendering, right? And the reason why it doesn't, because I have forgotten to run the Tailwind compilation again, right? So that happens, but it's not a big problem. It's just something on our place, right? So how is everybody's installation going for npx create expo app?
Mine's done.
Done? Okay, pretty good. Right. I don't know if it is my internet. It shouldn't make my system. My system is pretty strong enough, but hey, I'm waiting for my 5,000 to get to 20,000. So we will wait on that. All right. But let's talk about what comes after. We already talked about the folder itself. Here you will have more folders in respect to, so now let me show you some of the similarities which will happen structural similarities of what you're already familiar with and what it is called in this particular environment. Okay, the first and foremost is we created media, and then from media, within media, we had images, and then we had all of these audio files, and then we have these video files and stuff like that, right? But here we just put all of them inside assets, and then inside of that we can create IMGs, separate subfolder if you want to, right? So that is one of the similarities. The second thing is when you're developing web systems, right? You develop pages. That's the folder that you give where you put all your HTML files. Sometimes you call it HTML, which isn't what you should technically call them, but sometimes, or mostly sometimes you will call them as pages, right? And what you put inside of these pages is things like contact us.html, right? Or you can have projects.html. So you have all of these different HTML files and you kind of put them, other than your landing HTML file, inside of the subdirectory called pages. So we don't have pages on a mobile phone. So what we call pages as are basically screens. Okay, so we're going to write them as screens, and they are going to be something like contact.js, because we're going to be writing it in JSX syntax. Sometimes you will see that if people are using TypeScript, okay, they will be having the extension for TypeScript itself, TSX, or sometimes people will be having the extension for JSX itself, right? But generalizing it, it is contact.js itself. But the way you store them or way you structure them in your project directory is within the subfolder called screens, which is going to remain somewhere here right after assets and stuff like that. And from React.js, there is a folder which is going to be present here as well. And we are going to call that folder components. So just like in React.js, the purpose of these components is to contain your custom components, which are nothing but functions that you will call in different screens. You will have components here as well. So what you will do is you will develop the screens, okay, and you will call the components within those screens, right? So that is how the nature of the hierarchy is going to be established. Is we will have a landing page, which is app.js. We will have multiple screens. If your app has or requires multiple screens, that is up to you and your design. But if there is screens, you will store it in a separate folder called screens, and you will put them there. Then you will create a separate folder like you did in React.js called components, which will store all your custom components. And then depending on what type of component you need in whichever screen, you will just make a function call to it. And then finally, what you will do is you will take all of your screens that is there within the screen subfolder, all the files that is present there, and you will put that, you will kind of bring them together and consolidate them finally in your app.js. So remember, just like in React.js, we had an app.js, which brings together all of the different components that you have in your React.js project. You will use the app.js file here in this environment to consolidate all the screens that you have, okay? There is no concept of an index.js file which connects to an index.html file because there is no concept of web browser DOM here, right? So app.js essentially becomes your landing page and essentially the page which is going to bring together all of the different screens, which is calling all of the different components that you're going to develop, okay? All right, so my installation is done as well. So I believe I'm the slowest, but as a result of that, I hope all of you are done with your installation as well. Did anybody hit an error? Did everybody's, whoever tried, did their installation go successfully? Yes?
What was the question?
So my only issue is that I'm not seeing that expo file. Did you have to make that separately or did it automatically create it?
No, you don't have to. So let us check my installation here. So you don't have to make that file separately. Don't worry about it. If it doesn't show, it's okay. It's okay.
All right. Okay.
Okay.
Then I'm all set.
But do you see this message at the very end that your project is ready and all this stuff, right?
Yep.
Then your project is ready. Good.
All right, good.
All right. So moving forward, we have already discussed about the directory structure here, but I will just show you open the app.js file. This is the boilerplate that will be generated for you. This is a landing page. It doesn't have any components and stuff like that. So the status bar is a component that is coming from the Expo library, okay? But notice that these components, which is style sheet, text, and view, view stands for division, text stands for any textual data that you want to be rendered on the screen. Style sheet is basically to add styling rules that is written in JavaScript. Okay, so these are the comparisons. All right, so we are basically bringing this input, we are destructuring this input, as you are familiar with destructuring here from this particular library here. The first starting point of any kind of screen that you write or any kind of component that you write is going to be very similar to writing a functional component in React.js, right? But this time, instead of creating a functional component in React.js, you will be writing a React native functional component with export. So you see, there are two different snippet options that you have in this particular environment. You can either create a React native functional component with an export statement, okay? Or you can create a React native functional environment with a styling component. So you have two different snippets from your extension support to create boilerplate code within this environment, okay? So that means, let's say, if I go ahead here within this My Expo app, which is the app that I installed, let me just create a folder for components. Okay, inside this component, I can go ahead and create a new file here, and let me call this test component. Okay, .js. So now if I want to create a boilerplate code here, I can write RNFE, which is going to create a React native functional component with an export statement. So hit enter, and that will generate the boilerplate for you, just like it did for your React native environment. But in addition to this boilerplate code, you also have another snippet, which is React native functional component with an export statement and a styling component. So that is RNFES. So if you hit RNFES, you can see here that the style sheet component is also created for you as a boilerplate, if that is what you want to use, right? So those are the two different options that you can work with. Essentially, once you export this, you can kind of bring it in your app.js file as well. We don't want to do that right now. We will just leave it there. Remember, I also told you that you can combine the export statement with your component declaration as well, right? So this is what these guys are doing. Instead of having a separate statement here at the bottom, which says export default and then app, which is how you have seen the export statement happen. We are doing it twice here. So that is what the error is all about. So either you can choose to do it separately, like I've shown here, or you can combine your export statement in your app declaration or your functional component declaration, which is export default functional component name, right? Then you have the return statement within which you're going to write all of the code from React Native core components and everything else that is there. Between these function declaration and the return statement is where you can write all your app logic using JavaScript or any kind of React.js. And we already talked about the style sheet, right? So now the next thing that you want to do is basically switch into your app folder that you have created. So I'm going to go into CD, this is the app that I created. So I'm going to go here and then I'm just going to hit Expo Start. Okay, so that is basically the command that I will use in order to run my project and get my QR code. Okay, so again, I will repeat the two steps that I did. If I went a little bit quicker, I will CD into the directory that I just installed using npx create expo app, which in my case is my expo app, right? So I moved into this, and when I compile and build this process, this .expo folder will show up. Okay, so that is after the build process is done. In order to execute the build process, the command that I used here is the expo directive. Remember, the first command that we installed was the expo CLI. So this is allowing me to kind of install this. And the second one is just expo start. Okay, so once you hit start, it will run what is called the Metro bundler. So that is responsible for performing that whole compilation of your entire project. And it will give you, notice these few options. The first thing that it gives you is a QR code. So we can go ahead now and download our Expo Go app from the Play Store or Apple Store library. And I cannot find my installation here. Okay, so I have an Android phone. So I'm going to go to Google Play Store and I'm going to search for Expo Go. All right, and then update that for I have already installed it. So you guys can go ahead and download the Expo Go app. Essentially what happens is once the app is launched, you scan this QR code and you should see this app deployed on your cell phone itself. Okay. The other option is if I press A, it will open this app in the Android simulator, which is Android Studio. And in the next class, I will show you how to work with that. I don't have a Mac, so I don't see the simulation option in Xcode, which is the simulator for iOS platform. So if you are a Mac user, please install this software called Xcode. The installation instruction is there in the second React Native Part 2 slides that we have. So you can go ahead and do that. So if I press A after the Android simulator is running, then essentially Expo will take my app here and launch it on my simulated device. Okay, but for now, for today, in the next class, I will show you the simulated devices. For today, install your Expo Go app on your cell phones. And then once you open it, it will ask you for permission and stuff like that. So I don't know how I can show you my screen here, but it will have two options. It will ask you to enter the URL manually. So this is the URL that I'm using if you ever need the URL support, or it will ask me to scan the QR code. Okay, so I will scan the QR code myself. And it for the first time, it will take some time to compile all of your stuff. Once the bundling is done, you will essentially see the information as this. I don't know if you guys can, it should not show it because I have it blocked, but did anybody get to this point where you were able to run the Expo Go app, scan the QR code and see this application on your phones? Anybody tried it out yet?
I ran into some like forgotten passwords and stuff, so I won't be able to try it this time.
Forgotten passwords?
Oh, like I forgot my passwords to certain things to log in that I need to
install your app?
Yeah.
Okay, but anyways, remember this, the main command is Expo start. It will generate these QR code. And then what you can do after that is you can play around a little bit with this app.js code that has been installed for you, maybe change the background color and stuff like that. So maybe if I change this to, let's say, F to 3, I don't know what this is going to show, but I can see it. I don't know if the red color, you can see that's using the filter, the color is red, right? And I can show you that I'm not just making things up. I can kind of change this to F to probably, give me a value, F to F. I don't know what will happen here. So if I do F to F, you can see here immediately in real time, my screen color changed from red to something like a lavenderish. Okay, so that is to show that I'm not making things up for you guys. It actually does work like that, the way it does. So you can see like real-time updates for the changes that you make to your app. And that is why I love this method better than simulator, because it's not slow. The simulators are going to be slow, and it is also codependent on how much your system can support those simulators, which requires a lot of spec. But this method is pretty nice to see because you can actually see on the device that you're planning to deploy it as to how it is going to look like, right? So in the next class, we will continue this discussion with the installation of the simulators. I would request for those who would like to work with the simulators, and you have to work with the simulators, to kind of go over the instructions and pre-install, because that simulator installation is going to take some time. It's a 10 gigabytes file in total, at least for Android Studio. I don't know what's the sizes for Mac users, the Xcode, but try to install it prior, okay, before we meet next Tuesday. So we are up and ready and we can focus on the app development specifically. All right, so I will see you guys again on Tuesday. All right.